chapter 4. Find, let's say the zeros. Implication, find all of them. And here's my function, polynomial function, it looks like this. And I made it fairly short here. Let me step back away from the board, make sure everything looks good. Now, that looks good. Degree 3. So I'm gonna get 3 zeros. The one on the quiz tomorrow, probably for the quiz, I'll probably keep it the max 3. Find 3 zeros. The exam on Friday, If you looked at the review for the exam on Friday, I think that one had 5. That's one review problem. Okay, tomorrow we'll keep it brief though. Guys, looking for 3 zeros. You're saying, well, Professor, I know you're gonna ask me about Descartes' rule of signs. So I go through and count the number of variations, guys. I see 1 here, none here, 1 here, and it looks like the number of positives, let me go through this, zeros, which we've done before, with the variations in signs to be only 2 here, so I could have 2 or none, exactly. Now the number of positive, negative, positives out of the way, of negative real zeros. Supposed to now find p of a negative x and count the number of variations in signs there. Guys, let's do it fairly quickly. Replacing x with a negative x, you simplify. That first term looks like this. Second term stays the same. Third term becomes, I think, a positive. And then plus 18. And step back and look and see if you guys agree. Replacing x with a negative x and simplifying. Is that true, guys? Variations in signs, none here, 1 here, none here. So of those 3 zeros I'm expecting, we could get 1, we'll get 1, negative. So right there it tells you, when you start testing, you may want to test the negatives first, the negative possibilities, and find that 1 negative is promised. Now though, as a professor, now I want to find the zeros. So right now, all we have to work with is synthetic substitution, and I have my numbers like this, and we're going to start testing. -9 there. Now, where do the test numbers come from? That's called the rational zeros theorem. What are the possible rational zeros here? And guys, that's a P over Q. We've been using in class. The P represents what? Factors of my constant term, 18. And I like to write it like this. These are factors of 18. And do not let me leave anything out. I think that's it. The Q, factors of my leading coefficient, which is 2. Thank you, it's not too many. I got that. Now, I'm not going to ask you to list all the possibilities. But I think by now, every student in class realizes you got to go through and start forming possibilities, and then start testing. Now, if you want to look for this one first, which is promised, I can find it, or we could find it. I want to point out something, though. So students are asking, Professor, where do I start? What should I test first? And this is really sometimes up to you what you want to test. And if you want to search for this one first, you could go through to test the negative possibilities until you find it. But I did this for a reason. Please tell me, is 1 a possible zero at this moment? I mean, should I test 1? Is 1 a number that needs to be tested or could be tested? Would it come from, is this 1 over 1? 1 over 1. Does that form 1? So is 1 a possible answer? Yes, so I'm going to test 1 just to see what happens. Guys, there goes 0, 2, 2, -3, -3, help me out here, -12. Looks like a 12, looks like 6. Now I did that fairly quickly. I got 6 on the end. Now watch, skip what I want to point out here. Did it work? No. It's a way professor will get frustrated. Sometimes that first number you test may not work. Then you have to start all over. And I want to point out this. And say, Professor, I'm going to test now. Let's see if this is going to work out nicely for us. I want to test 2. And by the way, guys, is 2 a possible test number? Yeah, I got 2 over 1. You start listing all the possibilities of P over Q. So 2 is a possible. Test it. 0, 2, 4, -1, -2, -11. I think it's a -22. I did it quickly. I got a -4. Is that true? I did it quickly. Darn it, it didn't work. Did it? And then you're going to start getting frustrated. But guess what? In your search for those zeros, something special happened that you did not realize could happen. That's why I sort of held off on this until today. No, this did not work. Besides not working, guess what this tells me? When I tested 1, I got 6 on the end. The benefit is amazing. If you should now go back and find P of 1, you went back to this polynomial function and replaced all the x's by 1, and be patient and calculate, guess what you'll get for an answer? 6. So rather than direct substitution, going back and directly replacing by 1 and calculating, why not use synthetic? You'll get 6. It's not what I wanted, but you'll get 6. If I go back and put a 2 in, look at this. Directly, will take a little time. 2 cubed is 8. 2 times 8 is 16. And you go through and do your business and calculate and get an answer for P of 2. Guess what that answer is going to come out to be? -4. So that's one benefit of this. It's not what I want right now at this moment, but that's one benefit. So this is saying right here, it's a benefit for me that P of 1 is 6. This one says P of 2 is -4. Is that true? I love this. It's not exactly what I want. Now, something else that's coming out in this example here, to point out something here. P of 1 is equal to 6. If I should ask you to graph this thing, this means an ordered pair, 1, 6, is on that graph. This, in terms of graphing, means 2, -4 professors on that graph. Watch carefully, I'm not going to graph it. Now, let's use a little common sense here. In terms of graphing, we are guaranteed right now with what you see right here. This point, out 1, up 6, will be, if I should graph it, will be on this graph. Out 2, down 4, is going to be on this, the graph of this. Guaranteed. What I want you to take notice is, where is 1, out 1, up 6 located on the grid when I plot it? Give me a good sense of where is it? Out 1, up 6. Give me a good location. Where is it? Out 1, up 6. I know it's on the graph. It's going to be on the graph. But tell me more. Be more specific. Where is it? Out 1, up 6.
First quadrant.
Thank you. First quadrant. Is it above the x-axis? Where's this one? Out 2, down 4.
Fourth quadrant.
Okay, out 2, down 4. I'm here in fourth quadrant, or is it below? These two are supposed to be on my graph. They should be connected. So if I go from here, out 1, up 6, and he was describing for me where it was, but out 1, up 6, guys, we'll say it real quickly, is here. And all of a sudden, out 2, down 4 is somewhere in here. You guys agree?
Yes.
And then my graph itself, I don't know what the graph looks like right now. I don't. But I do know these 2 points have to be connected. It may do something like this. Who knows? I don't know. But I got to pick up those 2 points. Those 2 points are on there. Now, what am I looking for, though? I'm looking for the zeros. That's it, thank you, I'm looking for the x-intercept. And look, that's where it is. Is it caught between, right, here's my x-intercept. Is it caught between these two? So that guarantees me there's an answer over here caught between 1 and 2. So when I start testing, you may want to go to me and say, Professor, I'm going to start testing numbers that are caught between 1 and 2 of your possible collection here. And I'll test it. Now, does anyone have in mind, I'm not going to list all of them, when you put P over Q, does anyone see up here maybe one that would fall between 1 and 2, because you're guaranteed since 1's up here, 1's 6. And 2 negative 4 is down here. When you connect those two, which you must do, you've got to cross the x-axis. I heard it. 3 halves. 1 and 1/2. It's 1 and 1/2 between them. Guarantee you. Now, I'm almost a guarantee. Here we go. Guarantee you. Let's test 3 halves and see if 3 halves works. 1 did not work. 2 did not work. Now let's try 3 halves. I'll put this in red here. Same numbers. Here we go, guys. 0, 2. I think you get a 3 here. Watch my math here. -2. I think you get a -3. -12. I think you get a -18. It works. Oh. Does it work now? So I've found, I'm looking for 3 here. I've just discovered 3 halves, 1 and 1/2 works. With the help of the knowledge of this one did not work, this one did not work, but their locations gave me a hint on what might work. Since one's above the x-axis, the other one's below the x-axis, they didn't work, but connected, you gotta cross the x-axis. As soon as you cross the x-axis, there's a 0. And you start searching. And sure enough, in this case, it came out to be 1 1/2. 1 1/2 is caught between 1 and 2. And it worked. Now, if that should happen, I've got 2 more zeros here. I think every student in class now would know, since 3 halves works, maybe I can find the 2 remaining zeros, Professor, by not testing, but rewrite this as, since 3 halves worked, it was a cubic. As soon as I found one to work, it dropped down to a quadratic. So those numbers there, name a quadratic for me. Written like this. 2x squared subtract 2x subtract 12. No more testing needed. I need to solve that and find the other 2 zeros. Guys, I'm going to divide by 2 to make it easier on me. This is x squared subtract x subtract 12, I guess. Yes or no? Is that true? Now, will that factor? If it will factor, I need not use quadratic formula if it will factor. Does it factor, guys?
It should be 6.
Where was it?
It's minus x minus.
Negative 6 here.
No, up there.
Over here, when I reduce it down. I said 12, 6. Now, x squared subtract x subtract 6. That will not factor. After I reduce it down. If I use, or will it factor?
Yeah, x
Oh. Into what?
minus 3x
X subtract 3 and x what?
plus 2.
Plus 2. Are those the other 2 zeros? Did they factor? Now, would that be a big help? Okay, would that be a big help if you took note of that? Now, sometimes you get so busy testing, you get aggravated, you'll test a number, it didn't work, you get aggravated, you just throw it away and forget it. But you might test another one, you say, oh, there's a sign change. One's above, one's below, there's a sign change. They didn't work, but the outcomes had a sign change. That means there's an answer called between. That's a big benefit. Before I leave this, let me write this thing real quickly in factored form. What I see here stuck on the board. P of x in factored form, guys. 3 halves written best as what? Is it 2x subtract 3? If we're correct over there, 3 also worked. Factor x subtract 3. And also it looks like a -2 worked, x plus 2. Is that it? In fact, form. By the way, didn't Descartes' rule promise me that there was a negative zero to begin with? Is that true, guys? Did we get just one negative zero? Yes. And Descartes' rule promised me that, and we got it. It was -2. You could have tested -2. So I thought I'd point that out. Don't get aggravated on the exam or the quiz. If your first number that you test does not work, I know sometimes I will get aggravated, and then you test a second number, and all of a sudden you see a sign change. That means there's an answer caught between. So go back and see if you can find it and test it. Yes?
You have to factor 2 out of the 2x squared. You have to factor 2 out of the 2x squared.
You don't have to.
You don't have to.
It makes it easier for me. It becomes this.
Bring it back in when you're, putting it into the other form.
No. Look at this though, I think I see what you're doing. Right now, just visualize. I'm not gonna multiply all this in the red out. If I should multiply it out, guys, with my first term, agree with this. If you should multiply this times this times this from algebra with that first term become 2x cubed. Just the first term. So I feel good about that. Yeah.
If you don't take the 2 out, does it still work?
If I don't take the 2 out, where?
From the 2x?
Oh, right here, you say what you want to do with the quadratic formula, or,
Doesn't it factor into 2x minus 6x plus 2?
well, you may get something to repeat. Let's see what that is. You did not take the 2 out. Okay, Philip, got me out here. You're gonna try what, 2x and x?
And then minus 6 plus 2?
Minus 6 here? Well, let's do it, make sure it works out. Minus 6x plus 4x minus 2x minus 12. And then you say, Professor, what would I do? Now, do you want to set those equal to 0? And it looks like I'll get 3 again. I think I got 3 earlier, didn't I? Now we're gonna get -2. Do we get the same zeros?
But then what about when you plug it back into the p of x?
No, hold on. If you plug it back in, you want to put an additional 2 back there? It's not gonna work out. That's why I asked you, if you visualize all this as the red multiplied out, you better get the first term to agree. And my red, if you multiply it out, the first term will be 2x cubed. If you put that additional 2 in there, you'll get 4x cubed. I understand your reasoning though. Yeah.
I put -2 on the chart, but it was really actually working too, but it,
Wait, you tried -2 here,
yes.
and it worked?
Yeah, but it comes out different equation.
Oh, well, of course it could come out different if -2 worked. And we said, oh, I got you, -2 here.
No, in the first one?
You tested -2
Yes.
by synthetic.
Yes.
I got you. Now you saying this, I'm glad I brought this in before we get a good start here. Let's see what she did. I think I know what she did. So you tested like this?
Yes, sir.
Beautiful. -9, what was it, 18? I guess that's what, 9, -18, 0. Got that?
Yes.
And then did you try to do anything with this?
Yeah.
This is 2x squared, subtract 9x plus 9 is equal to 0. Right?
Right.
Did you factor this, or does it factor?
Yes.
I hope it factors as a factor. Or you can use quadratic formula. Was it 2x and x, guys? Help me out. Does it factor?
Yeah.
Yeah, -3 and what? -3? It works. Thank you. Thank you. That's another possibility. It does work. Okay, so guys, it's just out there. So you want to start grabbing whatever to make things work. I'm just saying though, if in your work, and I may give you a hint, especially on the exam Friday, that one does work like this, take note. Professor, I get discouraged, it didn't work. I got discouraged again, Professor, it didn't work. But they're different signs. So one's above, one's below. Therefore, there's an answer called between the two. In my case, it's 3 halves. Now, Rena, read to them, it's on the other handout. Read to them, it's called intermediate value property.
Let f denote polynomial function if a less than b and if f of a and f of b are opposite signs, there is at least one zero of f between a and b.
Now, she says, Professor, if f of one, in my case six, and f of two, which is -4, if these two outcomes are of opposite sign, in other words, one's above the x-axis, the other one's below it, you're going to have a zero between. And it's called intermediate value property. When you get to Math 7, which will be shortly for us, you'll be in Math 7 before you know it. They call it intermediate value theorem. They do a little bit more with it. Okay, intermediate value property. Right? Make sense? Woo! I love the discussion though. I love what she told me when she said, Professor, I tried it a different way because I love that. You see the creativity. She tried it a different way. She said, Professor, I tried to test the negative too because I was trying to find that one negative zero from it. And it worked. But I want to point this out also. It's intermediate value property. Okay, guys, and get that out of the way before I jump in and do more. Good discussion there. Now what I need, and I think most of my students probably realize, Ramsey, you have not, there's one more item you have not finished up yet. Before you jump back into and get chapter 4 out of the way, can anyone remind me? What may be an item that we have not touched upon, and I should touch upon before I move any further? There's another rational function type that I have not done yet. I held off. I think did I do a rational function yesterday? Yes. Now maybe on that handout we had 4 problems at the bottom, was it? At the bottom of the handout? Now, Rena, since you're close by, check and see, is there one there that we have not touched upon at all? Please tell me in terms of the degrees. Is the degree on the top exactly one larger than the degree on the bottom? That's what I need. Finish this up. Because it's a little different. Okay, so guys, rather than throwing all those rational functions at you in one day, you'd be overwhelmed. We'll get this out of the way here. Okay, guys, we'll call this, I'm just call it part 1 again. Rita, would you read that function for me?
X squared minus s minus 12
Minus 12, okay.
over
X plus 1. Here we go. This is the last of the rational functions until you see one on the exam on Friday. I have one for you. Guys, look at the degrees. If when you examine the degrees, highest exponent, and the numerator and denominator, and the one on top is exactly one larger, it'll be exactly one larger than the one on the bottom, in this case it is. You have an unusual asymptote, not vertical, not horizontal. You may have a vertical, yeah, but not horizontal. It turns into another type of an unusual asymptote, and it's known as an oblique. You say, Professor, when can I expect this, and what is it? We're going to grab this. Oblique asymptote, not horizontal. This is going to be an oblique line, a slant. Not a horizontal line, a slanted line. It's going to be your asymptote. And since it's going to be a line, I would expect its equation to look something like this. MX plus B. Okay, guys? Now I have to only if the top one is one larger, exactly one larger. Some of my students, I know what you're going to ask. You're saying, Professor, suppose this has been x to the 4th, and this has been x squared. And the one on top is exactly 2 larger. Yeah, that gets even more weird. So we're going to stick with it for this class where it's just 1 larger. So I can get something like this. Okay, guys, let's run through this right quickly. Number one, I'll have all these steps, on the test for you to follow. Step one, I think, was to list the domain right quickly. Well, the domain in this case is this. That's obvious. Two, I think I asked you to simplify it. And I could factor the numerator. I'm gonna quickly, so watch for errors. And it looks like it might factor into that. Done, you get partial credit for all this. Number three, the intercept, I think it was. X-intercept, you replace R of X, Y by 0. And since I have this already factored, I'm gonna leave it in that form. Simplified version. Like that. And I would quickly cross multiply, or just say, Professor, I see right now, it just comes down to this. X subtract 4, X plus 3 must be equal to 0. And we'll put the 0 over 1 and cross multiply, it's up to you. You'll get that. Split this up, some here, we'll end up with a 4, looks like a -3. And these are x-intercepts, so we'll write them guys as 4, 0, -3, 0. Do we agree? Y-intercept. Look at all this partial credit you get. Y-intercept, you know how to find a y-intercept. You go back and replace x by 0, in other words, r at 0. Guys, if I do, I'll do it right quickly. I think it's a -12. Check my work there.
Yes.
Out. Is it -12?
Yes.
Get it quickly. Number 4, if there are any, I'm looking for vertical asymptotes. Now, how does one find those? Set the denominator equal to 0. So that's x plus 1, that will determine my location. So I have one vertical asymptote. Now, number 5. I think to check your handout, the next was asking for a what, horizontal?
Yes.
Asymptote. If you've already identified that there's this one, in other words, the degree on top is exactly 1 larger than the degree on the bottom, there is none here. It turns into an oblique. Only that one case there. So here we'll put none, need not check it. And number 6, we'll finally have one of these. An oblique asymptote, a slanted line. In fact, some textbooks will call this a slant asymptote. Okay, no horizontal. A slant in this case. Now where is it? I got to put it on the grid because my graph is supposed to follow it. And it's supposed to look something like this. Not this. There's no horizontal. There's a slant line acting as an asymptote. Guys, it's a unique way to find where it is, what it is. You've got to go back and do something that you have not done in math probably for a long time. You've got to do long division. You've got to divide back in your function, divide x plus 1, the denominator, into the numerator. You got to do long division. Now, I don't know how long it's been since you've seen long division, and I'm talking about way back when that elementary school teacher probably gave you something like this. I'll make that one up right quickly. It looks like that. Remember doing that? Long division? They call it long division here. Remember the process? They want to remind me, back in elementary school, what did they do if we did it back in elementary school this way? What did long division do? You ask yourself, how many times will 13 go into 34? In this case, twice. That's most. Then 2 times 13 gives you a 26. It's a little process. Then you subtract. And start the routine again. 34 subtract 26 at this point would be how much, guys? 8. And you bring down your next term. And start the process again. 13 into 82 at most, what? How many times is 13 going to 82 at most? Help me out. I think 6 times 13 is what, 78? I think that's about the best we can do, so 6 times 13, 78, I'm hearing. And I'll finally subtract again, in that process of long division, and you end up with a 4. Does anyone recall now what, which is at the end of my process? Can't go any further, I can't take 13 into 4. What was that 4 known as back then? Remainder. This is your remainder, if you need it. And some of my students may have seen long division expressed another way. This was called the quotient. So I got a quotient, remainder, I have a divisor, and a dividend. Some vocabulary. But I'm more interested in the division, long division. Guys, I gotta do this that you saw before somewhere on this. And hopefully end up on top here, not with a number like in elementary school, but a form that looks something like that. You all know where this oblique, slant, asymptote is. It's supposed to be a line. But you guys, what we're going to do first here, I'm going to ask myself, how many times will x go into x squared to start? Something like 13 into 34 here. X into x squared, guys, will go 1x. Then we'll do this. 2 times 13, I think I've got 26 up here in the elementary school problem. Here we'll get x times x, down here, x squared. And then x times a negative 1, negative x. That's x times this, up front. Then we'll do that subtraction that we did back then. And subtraction for us says just merely change these signs. And looks like we lucked out here, guys. Looks like the x squareds drop out, the x's drop out, sometimes they don't. And I'm left with a negative 12. Now, is that my remainder? So my remainder. So I'm left with, at this point, on top here, I'm looking at the top part. I would like for it to be in this form here if I could, because that's going to act as my oblique asymptote. Can anyone tell me, can I write real quickly that top quotient in this form? I see x on top.
X times x plus 1 minus.
No, something easier than that. Just rewrite x for me, but put it in the x plus b form. Slope intercept form for a line, because this is going to be a line. What might it look like? Go for it.
Could it be x minus 12?
Nope, something easier than that. Because I'm finished. I can't do long division anymore.
X plus 1.
I can't take x into a negative 12. That's my remainder, so this is going to stop. I don't need this. I just need that top part. Then how would you name it? Yes? Y is equal to x. Or x plus 0. That's all you have. Now it looks like this. Where the slope is understood to be, the m is understood to be a 1, and the y-intercept is understood to be what? 0. Now you have the location of this slant oblique asymptote by long division. Woo! But we're not on the grid yet. Yes?
Why is it x squared minus x first again?
Oh, right here?
Yes.
Yeah, because when I get this right here, you gotta multiply this times this, like I did this up here.
But isn't it x plus 1?
There's a minus 1 here, x squared minus x, and then you change the signs because you gotta subtract.
No, I mean,
No.
in the function is x plus 1.
Was there x plus 1 in the function? I'm looking for where are we?
Oh,
Like on the left, top left.
Did I write something down wrong? Oh, back here. You're looking at, let me see where I am. Was it x plus 1 here? You're saying right here. That true, guys? That's what you're looking at. Watch, because I'm doing so quickly here. Okay, x squared plus x, I got x squared plus x now. We do this. Then you're saying, I got you, I see what you're saying. Professor copied that wrong. Now, if I change these signs, are you saying now change them like this? Where the x squares drop out? Now, will I get though now what down here? Was it negative 2x? And then minus 12. Now, if that's true, can I now continue further than what I thought previously? Can I take x into a negative 2x? Can I continue up here? And get what next? I heard negative 2. Could be pretty up here. Jeez. And then negative 2 times this. Now, since I've corrected that, that's a negative 2x minus 2, is it? Subtract or change my signs. These two will drop out definitely now with a remainder of, looks like a negative 10, is it? And of course, I can't take x into a negative 10, so we stop. Delete that. Now I'm left with x subtract 2. Now tell me, what might that look like in the mx plus b form? Last time I had x plus 0. Now, what would this look like now? Is that x subtract 2? Woo. So that top part's going to tell me the equation of that line. And it's known as the oblique line. Wow, what a chunk of time I've used here on this. Now, it's needed. Now let's jump into it. Let's hope everything is now written down correctly there. Guys, let's pick up the items here. Intercepts, I got 4, 0 and a negative 3, 0. Got another x-intercept here and here. Y-intercept, if I look at it correctly, was down 12. Here. Vertical, I think we found 1. It's at negative 1. Place that here. My vertical asymptote at negative 1. Stepping back, horizontal none, of course, since we have an oblique. Now, guys, you got to put the oblique on there. That's why I brought this in today. It's a straight line. Looks something like that. Here's its name. Now, you can grab this using slope-intercept method, or you can find the x-intercept, y-intercept, and connect those to get the line. Now, guys, can anyone tell me right quickly, what would the x-intercept for this D? It's not curiosity. If you said x minus 2 equals 0, and try to find the x-intercept, where is that? It's 2, so I'm putting blue here. So out at 2, right here, is the x-intercept on that oblique slant asymptote. Use a different color here. Where's the y-intercept on the x minus 2? If I replace x by 0, I get what? Negative 2, so that's down here. Place it back here. That was here. Wow. So we connect those 2 points determine the line. Here is your so-called oblique asymptote. Something like that. I'll step out of the way here and look at it. Now please tell me at this point, do we have all the points on there? Do we have the x-intercepts plotted? The y-intercepts on there? The oblique? The vertical? Now, how many pieces are there to this graph? There's something happening on the left of that vertical, and there's something happening on the right of the vertical. You can plot points. See for sure what is happening. But you've got asymptotes you got to follow. So guys, does anyone have an idea where I got to pick up this point here on the left? I got to pick up this point and follow, not touch, the vertical And also now I've got another asymptote to follow, the blue. What might that piece look like? Any ideas? Crafting green. You gotta pick up this one here. And follow the red, don't touch it. And follow the blue. Do I have only one choice? Is that the choice? Does it pick up -3 like I should? And does it follow the red? In fact, it gets really close to the red on out here. And does it now behave like the blue here? As an asymptote? Yes or no? Now on the other side of the red, I've got to pick up that point there and that point there. And what might that piece look like if I pick up those 2 points and also follow the 2 asymptotes? That's why they're there. Got to pick up this, and follow the blue, follow the red. What do you think that shape may look like? I don't think I have much choice. Does it look something like this? Yes or no? And that is it. That's the way the graph looks. Now, if you've had this course before, who knows, you may have. Some students have, maybe for the first time, have never seen this. What on earth is an oblique asymptote, Professor? We finally discovered what an oblique asymptote is. Your graph could look something like that. What are you hoping for on the exam Friday? When I give you one, I'll give you one. Rational functions graph, and you have to go through all these little steps here. What are you hoping Ramsey gives you? You're hoping for a horizontal, aren't you? And you're hoping for the best case of a horizontal, which is when these do what? When they match up. That's what you're hoping, right? I hope that I win the lottery one of these days, but it may not happen. It may happen like this. Oblique asymptote. So look through all the different pieces there. Guys, it took a big chunk of my time, but I had to do it. So did we finally get that rational function? We got it done here. And then I think we did what? Intermediate value property earlier. We found some zeros. How's it look, guys? Now, before I leave this, just want to just take a little practice with you guys. Okay, here we go. You see what the graph looks like. Suppose on the function, go back here, make sure I see it now. This is x plus 1. X minus 1 like I copied, or x plus 1. And you're asked to find this. All right, 250. And I'm sitting at my desk watching you as you take your test, and I see frustration in your face. And the man's crazy. He's asked me to go back and put in 250 here and square it, 250 here, do my business, then jump down here and do 250. The man's crazy. You want to see what I'm looking at? Looking for on this particular one. I went, R at 250, are you going to directly replace those x's by 250? Of course not. That's not what I want. If you want to, go for it. That's not what I want. But you want to see what I want based on my graph? R at 250. So we'll see. And by the way, I stopped at 4. 250 is out here. 250 is way out here somewhere. I'm trying to find R at 250. Someone tell me in this clever class, what would you do? Say, Professor, I'll give you this, and then I'll move on. So,
Could you still get back
would you, look at this, it'd be easier if you went back here and you say, Professor, put that 250 back here, not here, Professor, I'll be here all day, put it here. 250 subtract 2, that's 248. Now, that's not exactly what I want, that's approximately 248, that's close enough. Now, why is that reasonable, to put it here on this particular problem and not back here? Go for it.
Because it's following the oblique asymptote.
Absolutely. Is it getting closer to the blue the further you go out? And 250 is way out. Is that true? Are you much closer to that, where is it again? The blue oblique? My graph itself, the green? So why not use the oblique to approximate that? Did anyone actually plug in 250 for me? I don't think so. I guarantee you, though, you're close to 248 if you do. Replace those x's by 250. Okay, guys, I'm leaving it. Done, finished. I feel good. As an instructor, we've done what we had to do here. I had to clean that up first. Now, geez. Mr. Park.
Mm-hmm.